Next one is the aircraft flying crossing this meter is height is given, and also the pressure, that means atmospheric pressure is given, is kPa, and ambient temperature is given and declared in the diffuser. If enter the compressor is in the diffuser, and compressor is given to determine the stagnation pressure. So we have to find out the stagnation pressure of compressor, inlet, and required compression work per mass of stagnation rotation. And then Cp is given, compressor ratio is given, and Cp constant pressure is given, and also gamma is given. Okay, so we number A, this means we know the formula T1 if equal to T1, sorry, that formula will be T equal to T1 plus P1 square divided by 2Cp. Here this first temperature is given 250 plus 50.7 and plus V1, this velocity, then velocity is this velocity is given. This velocity actually we know from 250 250 velocity. Here we are looking at 5 meter, and this pressure is given. The inlet pressure is a diffuser is stagnation pressure, and then stagnation. Okay, here one line is missing here because it's very is coursing speed. One line is missing here. Here will be closing speed is the 250 meter per second. Here this speed will be the 250 meter per second. That line has missed. So 250 is into Cp. We know the 1, that means 1.5 into 1000, and after putting calculator you'll get the 86.8 Kelvin. That was the, and number also P2 we have to calculate. There stagnation pressure, for finding the stagnation pressure we have to know this temperature. The stagnation pressure P equal to P1 into T1, that means T initial, and divided by gamma minus 1. That is the formula. And just putting that whole value, and that P1 pressure we know the 54.5, and that initial temperature is given after calculator we have got that is 286.8, and divided by is the temperature is the temperature is the 255.7, and in 1.4 gamma is given 1.4 divided by 1.4 minus 1. Then we'll get this value is 80.7 kilopascal. That is answer. And number B is also easy. That means stagnation temperature. They are demanding. They are required the compression work and mass stagnation pressure ratio stagnation much. That means required pressure work per unit stagnation pressure ratio is given. Okay, that means when that ratio will be 8, and then we have to find out that. So we know, so we have to find out this number B. We have to get stagnation temperature. Stagnation temperature at compressor exit, at compressor exit. So for we know this formula is the T and T1 stagnation 1 and into stagnation pressure and P1 to the power -1 divided by kappa. This is the formula, and then we put the all values. We know 286.8 and that one's P2 equal to, this ratio is given, 8 and 0.4 divided by 1.4, and then after Kelvin. The compression work also we have to find out the compression work. So compression work in is the, we know the Cp divided by T stagnation pressure minus T1, that one, and there is that Cp we know is 1.005 kilojoule per kg Kelvin and 519.5 minus T1 is the 286.8. After calculating we will get the 233.9 kilojoule per kg, our compression work. I hope you have got this answer. Thank you.